30,000 parts. That is what one industrial humanoid pilot reported handling across thousands of hours of real plant operation. Not on a demo stage, but on factory time. For ordinary people, the fear shifts. Not the robot that dances on video, but the coworker that hauls steel. The paradox. The more the machine enters the floor, the more the question stops being whether and becomes under what terms. In this episode, why 2026 left the viral clip for documented deployment and what still belongs to human hands. In 2026, robotics' biggest fight stopped being the viral dancing humanoid and became the documented shift inside an industrial plant, and almost nobody separates the two cleanly. Notice the difference. It looks subtle. It is not. A demo is theater of capability, lights, clean floor, rehearsed task, applause. A deployment is another language. Accumulated hours, counted parts, logged failures, audited safety, unit cost argued with the board. Companies such as Figure, in public accounts of work with BMW and Spartanburg, have spoken of thousands of operating hours and tens of thousands of parts handled, figures reported by the firms themselves, still bounded to pilots and specific contexts, not a global verdict. Stanford HAI, in recent AI Index editions, tracks robotics and manipulation as a concrete frontier, not science fiction. Tesla, Agility, Unitree, and others race with prototypes and scale narratives. This matters for anyone who never set foot in an assembly plant. Treat demos as proof of scale, and you overrate substitution. Ignore pilots with hours and parts, and you underrate the regime change capital has already started to price. Keep the distinction, spectacle versus operations. Because the economics of manual labor already showed what happens when a machine leaves the lab and enters a space built for human bodies. Wait. The first mystery is not the robot's intelligence. That misread is expensive for workers and boards alike. Wait. The real mystery is the shape, and it changes everything in the next chapter. The physical world was built, millimeter by millimeter, for human bodies, and that is an economic fact, not a poetic metaphor. Bench height, tool grip diameter, aisle width, the box that fits one arm, the bolt hidden at an awkward angle behind a panel, all of it assumes 2 legs, 2 arms, roughly human stature, and hands that grip without crushing. A classic fixed industrial arm is strong and precise, but it forces the factory to rebuild around it. Cages, dedicated conveyors, parts placed exactly where the joint can reach. The humanoid sells a different promise. Enter the world that already exists and use what is already there. In that reading, human form is a capital interface. Not because it is the best engineering in the abstract, but because it reuses the vast stock of plants, tools, and layouts made for people. In other words, the humanoid does not need to be the best robot possible in a lab. It needs to be the robot that fits the fixed assets that already exist. That asymmetry explains capital appetite. Less civil redesign, more software, sensors, and hands. Carl Frey, in The Technology Trap, reminds us that technology and employment reorganize when cost and adaptability move together. Here, adaptability is geometric, fitting human space. Keep that, because the next distinction, fixed arm versus whole body, decides who pays for plant redesign and who only pays for the robot. See the contrast in concrete terms. For decades, industrial automation won, where the environment could be frozen, and lost where the world was messy. Welding in cages, paint booths, spot joints, the fixed arm shines. Internal logistics with mixed boxes, restocking irregular shelves, bolts at wrong angles, parts that arrive a millimeter off. The human hand still paid the bill. Humanoids attack exactly that gray zone, full body mobility, hand-like manipulation. navigation in corridors built for people. That does not mean they already beat a skilled operator at everything. It means the value frontier moved. The premium is no longer only brute force, but flexibility inside human space. Real engineering still wrestles with batteries, balance, failure rates, speed, and cost. Stanford HAI shows progress in manipulation and locomotion, not magic. Skilled operators still win on fine improvisation and on reading the feel of a part. The point is not to insult that expertise. It is to notice the economic premium shifts when part of the improvisation stops being rare. While failure rates and batteries limit long shifts, humans stay central. When those limits loosen, the conversation changes. The Nexialist point is simple. A fixed arm automates the cell. A humanoid tries to automate the aisle. One redesigns the plant, the other tries to inherit it. And when inheritance becomes cheap enough, the board's math changes. That math already has an anchor case industrial press repeated to exhaustion. Step onto the plant floor. The recency anchor that matters is not the dancing robot meme. It is the shop floor pilot, with metrics a company was willing to publish. In the BMW and Figure ecosystem, public communications described humanoids operating in Spartanburg, with thousands of accumulated hours and tens of thousands of parts handled, always framed as test and integration, not as a plant emptied of people. Treat those numbers as what they are: corporate pilot reports, useful to prove feasibility, insufficient to declare the end of the operator. Still, the economic signal is strong. When a global automaker accepts a robotic body in a real flow with safety, maintenance, and part counts, the debate leaves YouTube and enters the capital budget. Other firms publish demos and scale targets. The pattern is the same. Prove hours, not only viral seconds. Notice what accounting hears. Not that the robot is cute, but how many hours without serious intervention? How many parts per shift? What maintenance costs? What safety risk? While those questions have publishable answers, the pilot stops being a curiosity and becomes a budget line competing with hiring another shift. The WEF future of jobs has long mapped tension between task automation and new supervision skills. Here the tension gains flesh and steel. But a pilot is not a race. The race begins when several capitalists stare at the same cost hole. Hours and parts are the currency of industrial proof. Watch the peloton. The 2026 race has names the public already chants: Tesla Optimus, Figure, Agility, Unitree, and a pack of rivals. And what matters is not brand fandom, but the type of promise. Some sell massive scale inside their own plants and, at the limit, in homes. Others sell industrial focus first: logistics, parts, repeatable stations. All of them, in public materials, oscillate between demonstration and roadmap. YMYL safe. No universal adoption date is locked in. What exists are prototypes, pilots, and falling cost narratives. Investors watch latency, drop rates, hours between failures, retraining ease, and target unit price. Engineers watch torque, sensors, locomotion software, and collaborative safety. Workers watch whether someone will still stand beside them on the line tomorrow. All three lenses are true at once. There is also geopolitical and supply chain rivalry. Whoever leads in actuators, batteries, and locomotion sets factory standards. Separate noise from the balance sheet. A roadmap is not installed capacity. David Autor, for decades, showed that technology polarizes work. It squeezes the routine and rewards non-routine high judgment. Humanoids aim at routine manual work in human space, the physical middle of the ladder. The business question that remains is blunt. When robot capital cost crosses wages and benefits, what does the plant do? The capital curve answers before the moral speech. Brand noise is not the same as installed capacity on a live line. Draw the curve. Firms do not buy robots for poetry. They buy when capital cost, maintenance, and operational risk compete with wages, shifts, absenteeism, and rework. The classic automation curve is this. At first, the robot is expensive, fragile, and needs costly specialists to keep alive. With volume, learning, and cheaper components, unit price falls, and reliability rises. Wages and benefits in many industrial sectors do not fall at the same speed, and night, dangerous, or monotonous shifts carry a high human cost premium. Include what wages hide: training, turnover, injury leave, late shift quality drift. The robot brings energy, parts, fleet engineers, insurance, downtime. The honest comparison is total cost of ownership versus total labor cost at that station, not catalog price versus take-home pay. If corporate reports and public targets from humanoid makers materialize over years, and that is projection, not destiny, the crossover point approaches for specific tasks, not for all manual jobs. That detail saves the conversation from panic. A crossover at Station A is not the extinction of the plant. It is a redesign of Station A. Carl Frey describes technology traps where social adjustment lags technical adjustment. The machine arrives before society rearranges income and identity. Keep the mechanism, capital versus wages, task by task. Because the board's next decision is rarely turn off every human. It is another, more ambiguous, and more common in history: replace or raise throughput. There are two automation designs the public confuses and accounting separates. First, substitution, the same output with fewer people at the station. Second, throughput, the same people, or nearly, producing more volume, covering more shifts, clearing more bottlenecks. Industrial history, from the assembly line to farm mechanization, usually mixes both, but the fear narrative only hears the first. On real plants, the humanoid sales pitch is often the second: cover hard shifts, cut injury, stabilize quality, speed flow, without redesigning the whole factory. That does not make the transition painless. It can freeze hiring, change who gets in, and push value toward those who orchestrate fleets, quality, and exceptions. David Autor would flag polarization. The routine middle compresses, high judgment rises. In some contexts, low-end service remains. In practice, many plants mix both designs on the same line, substitute at a critical ergonomic station, and raise throughput in internal logistics. Net employment depends on the mix, the business cycle, and willingness to reinvest gains into volume. Throughput without career redesign is only a euphemism for compression. With reskilling, it is a different industrial policy. If this map of robotics on the factory floor is useful, subscribe to Nexialist Future and stay with Cycle 3. The series links economy, engineering, and identity without sliding into hype. Because the durable pattern was not born in 2026. It was born on the farm when the tractor arrived. Remember what the fields taught. When tractors and combines mechanized the fields, the naive forecast was the end of farm work. The real history was displacement, fewer arms per hectare, more total output, migration to cities, new trades in maintenance, logistics, industry, and services. Employment did not evaporate in a single apocalyptic day. The composition of employment changed across generations, with real suffering for those on the wrong side of the curve. Carl Frey, in The Technology Trap, insists on this. Technology creates aggregate gains and localized losses. Political time and technical time rarely match. City-raised readers forget rural transition. Whole families changed trades without a manual. The factory parallel calibrates expectation. Adaptation exists, but charges an unequal price. Pretending otherwise only delays friction. The lesson for humanoids is uncomfortable and useful. Uncomfortable because society adapts in the long run, does not pay rent for the person who loses a station this year. Useful because it blocks lazy prophecies of zero employment or automatic utopia. The durable pattern is a reorganization of the value of the gesture. What was scarce stops being scarce. Coordination becomes the premium. On the farm, scarcity of brute force fell. In the 2026 factory, makers bet that scarcity of flexible hands in human layouts will fall too. If that bet pays off in parts of the plant, the next historical mirror is the assembly line. It never killed employment. It changed where employment sat. Step onto the line. For its assembly line did not end work. It redefined pace, specialization, and the relative wage of the operator. Artisan tasks became stations. Volume exploded. New roles grew in supervision, quality, maintenance, and logistics. Decades later, fixed robots repeated the pattern in welding and paint. Fewer people in the cage, more people in programming, setup, and exceptions. And, in many countries, political fights over who captures productivity gains. Humanoids promise the next reel of that film, now outside the cage. The analogy has limits. The classic line strap the human to belt pace. The humanoid tries to inherit human flexibility. If it works at selective scale, industrial employment does not end. The mix shifts among physical execution, fleet supervision, robot body maintenance, and quality judgment. Another detail, the line created bargaining power in some eras and destroyed it in others when production moved or automated without a net. Humanoids inherit that ambiguity. Productivity does not distribute gains alone. Institutions do. Industrial employment changes shape before total volume, and volume depends on demand, not only robots. The World Economic Forum and labor polarization research describe exactly this kind of recomposition, with scenarios in dispute, not one magic destiny percentage. Before we close the economic map, though, there is a polarized question polite conversation avoids, and the shop floor already asks. It hurts. Institutions, not robots alone, decide who captures the gain. That is why it must be said out loud. Here is the polarized question, without anesthesia. Would you accept working side by side with a humanoid if it meant lower real wages but kept employment and raised output targets? Or would you refuse the mixed station and risk full automation of your role? The honest one-sentence answer: most people would negotiate the first if the visible alternative is the second, and hate the question the whole time. That is the concrete trade-off, not an abstract speech about the future of work. Unions, managers, and engineers will mediate versions of that deal under technical names: shift premiums, reskilling, productivity gain sharing, limits on which stations may be robotized. None of that is destiny. It is bargaining, and bargaining only exists while humans still have refusal power, and the plant still needs local judgment. When robot cost falls and reliability rises, the table tilts. YMYL safe. Nobody can promise the date the table tilts in your sector. One can only map the mechanism. If your first reaction was anger, keep it as data, not noise. Anger signals that wages and dignity are tied to the same gesture. Any mixed-station deal that ignores that becomes delayed conflict. The mechanism, though, is not only price. It is also who a person believes they are when they take the hard hat off. Manual worker identity enters the equation, and economics pretends it does not. Look in the locker room mirror. For many people, manual work is not only income. It is proof of competence, of dignity, of I do this and the world moves. When a metal body executes the gesture that defined that proof, the wound is not only budgetary, it is narrative. Psychologically, losing the rarity of your own skill hurts more than losing one isolated task. That is why fear of humanoids is not solved by a productivity chart alone. It is eased in part by new roles where humans still sign meaning. Calibrate, teach the fleet, decide exceptions, stop the line when the number looks right and the part smells wrong. That is not cheap consolation. It is a description of where value tends to migrate if the historical pattern repeats. It is also a warning. If a firm only cuts headcount and never redesigns careers, it buys social conflict at a short-term discount. There is also craft pride, passed across generations. A parent teaching a child to get the feel. When the feel becomes a neural net parameter, the cultural handoff breaks unless someone redesigns the rite of passage. From executor to fleet mentor, from part to system. Without that right, only loss remains. The Nexialist lens joins three things: economy, engineering, identity, because none alone explains real resistance on the floor. The next question is analytical. If the routine middle compresses, what rises and what fades on the skill ladder? David Autor already sketched the outline. Apply it to the plant. Labor polarization, in David Autor's reading and a generation of economists after him, does not mean everyone loses. It means routine tasks, cognitive or manual, are most exposed to automation, while extremes of high judgment and, in some markets, low formalization in-person services behave differently. On the factory floor, that translates as stations of repeatable, predictable motion enter the humanoid crosshairs, complex maintenance, ambiguous quality, process redesign, and safety management rise in relative price. Stanford HAI documents technical progress. The WEF Future of Jobs maps skills in demand and in decline across scenarios. Neither issues a single unemployment prophecy. The popular error is treating the humanoid as a universal substitute for the blue-collar worker. The accurate move is treating tasks as a portfolio. Some fall in price, some rise. Employment mix shifts. That does not license cynicism of the only elites survive kind. It licenses focus. Map tasks, not generic professional identity labels. Two people with the same job title can face opposite risk if one lives on exceptions and the other on pure repetition. The title misleads, the task tells. For ordinary people, the practical question is not, does robotics exist? It is my station freezable routine in human space, or judgment under exception? That question sets up three scenarios in dispute: cautious, selective, and a race without a net. Map the task portfolio before you map the job title. Choose with clarity, not with fandom. Three scenarios in dispute, all possible, none guaranteed. In the cautious one, humanoids stay in long pilots. Hard safety, few stations, unions and regulators on the brake, cost still high. Employment impact is slow and local. In the selective one, the most plausible in many sectors over coming years if the cost curve keeps improving. Plants adopt humanoids where return is clear. Internal logistics, hard shifts, bad ergonomics, stable quality. Humans move toward exception, setup, and orchestration. Total headcount may fall in some links and rise in others. In the race without a net, cheap capital and geopolitical rivalry push fast adoption with little transition support. High productivity gains, high social friction. Whole regions feeling the shock before reconversion. YMYL safe. This is a hypothesis map, not a calendar. Your sector may live the selective path while another lives the cautious one. Firms and countries can occupy different scenarios at once. One automaker selective, a supplier cautious, a rival racing for subsidy. That is why global forecasts of a single adoption percentage are often theater. The useful question is, which incentive dominates my plant? legal safety, unit cost, or fear of falling behind. What binds all three is the same mechanics: human form, capital cost, throughput, and identity. What remains is how the physical plant redesigns when leadership picks one of the three. Contested scenarios beat single percentage destiny theater. Enter the layout. The factory redesigned for humanoids does not look like a film of free robots in empty aisles. It looks like mixed zones, sensors, speed rules, collaborative cells, priority corridors, stations where humans remain the gold standard. Layout stops being only human ergonomics and becomes choreography of worker species, biological and mechanical. Training shifts. Less I only tighten the bolt, more I can restart the line when the fleet fails. Mark exceptions, read the robot health panel. Robot body maintenance becomes a trade. Operations data becomes an asset. Safety becomes the entry price, not an appendix. Day to day, this becomes a checklist. Who stops the robot? Who reviews failures? Who trains grasp? Who talks to the union? Without owners, the humanoid is an orphan asset, expensive and resented. With owners, it is throughput under human mandate. Status. Who owns exceptions owns value. Who only repeats competes on price with the machine. Firms that treat humanoids as marketing toys burn capital. Firms that treat them as socio-technical systems, people, process, machine, learn cheaper. That links to the previous episode on software agents. There, delegation was in digital flow. Here, delegation is in physical space. In both, someone defines goals, limits, and responsibility. Clear ownership turns a humanoid from orphan asset into mandated tool. Wait for the reveal. The sentence that sums 2 centuries of pattern without romanticizing the pain of those on the curve now. Here the pieces lock, and I want to be explicit. This is projection anchored in historical pattern and reported pilots, not prophecy. Serious automation rarely ends manual employment in an instant. It moves employment from repeatable gesture to orchestration, from brute force to exception, from a single craft to a portfolio of judgment. Farm mechanization and the assembly line already ran the film with different props. Humanoids try to restage it inside layouts built for human bodies, now with sensors and machine learning. What becomes abundant is routine motion in human space. What becomes scarce is the ability to see the system, stop what looks right in the number and wrong in the smell, and redesign the process. Do not wrap this as comfort. Moving hurts. The mechanism, abundance of routine gesture, scarcity of systemic judgment, fight over the surplus. The mask of the end of work falls and shows the older face of the Industrial Revolution. Recomposition of value, identity conflict, a fight over who captures the gain. 2026 is the opening of a deployment cycle, not a final verdict. Robots clocked in at some plants. The meaning of the clock-in, who directs, who gains, who teaches the next generation, remains human by design and by need. Operational moral. Measure tasks, not myths. Real hours, not demos. Bargaining, not slogans. You now see the mechanism. The final map is only to land without a prescriptive recipe. Let us land without a prescriptive career recipe. Only a map. First, separate viral demo from industrial deployment. Reported hours and parts matter more than applause. Second, human form is an economic interface because the physical world was made for people. Third, a fixed arm freezes the cell. A humanoid tries to inherit the aisle. Fourth, read capital versus wages task by task, not as a single apocalypse. Fifth, ask whether the plant seeks bare substitution or throughput. Employment politics change with the answer. Sixth, remember the tractor and the assembly line. Employment moved, with real pain along the way. Seventh, the polarized mixed wage question is not theoretical. It is bargaining. Eighth, identity matters as much as torque. Ninth, pick a scenario mentally. cautious, selective, or race, and test your sector against it without treating a consultancy percentage as destiny. Take the map into real conversation, family, team, union, board, without turning it into a dated prophecy. Its value is better questions before capital cost asks the question for you. Humanoids on the factory floor do not end the work of hands. They reopen the question of which hands, under which mandate, and who signs final quality. 2026 opens the cycle. The verdict is still in dispute. You have the map. Better questions beat dated prophecies. Use it with clarity. On Nexialist Future, we do not stop at the robot that clocks in. We move to the body that tries to turn back the clock. If this map of factory humanoids helped you, subscribe and continue Cycle 3 with us. Next episode, the first shot that tries to reverse aging. The first human patient in cellular reprogramming therapy. What science actually tested and what is still hypothesis. Tell me, if the machine already contests the factory floor, what changes when biology contests the body's time? See you next time.